Hello students, welcome back to my channel. Today we'll be dealing with chapter 4, carbon and its compounds. In that we'll be studying about allotropes of carbon. Carbon is found everywhere in your surroundings. In coal, desk, oceans. In pencil, that is lead is made up of graphite, which is a form of carbon. In sugar, the formula is C6H12O6, which contains carbon. Diamond is a form of carbon. In all the tissues of living beings, carbon is there. Also, you and I are made up of carbon. Gases such as carbon dioxide and carbon monoxide, that also contains carbon. Carbon is the sixth most abundant element in the universe. Now let's talk about carbon itself. It is an element. The symbol is capital C. It is a non-metal. The valency is 4. It is a tetravalent. It forms covalent compounds or bonds. The atomic number is 6. The mass number is 12. Its electronic configuration is 2, 4. All the informations about carbon you have already studied in your lower classes. Occurrence of carbon. Carbon can either exist in free state or combined state. When carbon occurs as an element, it is called free state. When carbon combines with other elements to form compounds, we call it as combined state. When carbon occurs as a free state, as an element, the examples are coal, diamond, graphite, fullerenes. These are all forms of carbon in free state. Carbon can take the form of gas, for example, carbon dioxide, carbon monoxide. Carbon can take the form of liquid in the combined state, for example, petroleum, vegetable oils. In solid form, carbon can occur in the ores such as limestone, dolomite, etc. In this video, we'll be focusing on allotropes of carbon. The property of an element to exist in two or more different forms, it's known as allotropy. We can classify allotropes of carbon in two forms, that is crystalline form and amorphous form. Crystalline forms of carbon means those substances which have a regular geometric shape. And those substances which do not have a regular geometric shape, it is known as amorphous. And the crystalline forms of carbon, they are diamond, graphite and fullerenes. Amorphous forms of carbon are coke, carbon black and charcoal. In this video, we will be studying about diamond, graphite and fullerenes. Carbon nanotubes are there also, that is CNTs, but for your syllabus, there is no need to study about carbon nanotubes. The crystalline forms of carbon are diamond, graphite and BUCKMINSTER fullerene. We are all familiar with diamond, right? Diamond is very hard, it's colorless, it has high melting point, it's transparent, it sparkles under light and it does not conduct electricity. Now, as you are a chemistry student, you have to study about the structure of diamond. As you see in the figure, the red atom shows that is carbon atom. And here, each carbon atom is linked to 4 other carbon atoms by strong covalent bonds. In the figure, we can see that each carbon atom is bonded to 4 other carbon atoms. Now let's see why diamond does not conduct electricity. We know that each carbon atom has 4 valence electrons. And all the 4 electrons are used in making covalent bonds. So there are no free electrons. Hence, diamond does not conduct electricity. Let's see the uses of diamond. Diamonds are used in jewelry. We know that it's used as earrings, nose rings, etc. Diamond is used for making glass cutters and also strong drills. That is, diamonds are used for industrial purpose. Nowadays, diamonds are used in making beauty products. Now let's see the next form of carbon, that is graphite. Graphite is grey to black in color. It is opaque with a metallic luster. It's very soft and slippery to touch. Graphite and diamond have different physical properties but same chemical properties because they are made up of carbon atoms. But the arrangement of atoms are different. We know that diamond is hard but graphite is soft, and this softness and streak make graphite useful in making lead for pencils. Now let's see the arrangement of atoms in graphite. As you see in the figure, each carbon atom is bonded to other carbon atoms by strong covalent bonds to form flat hexagonal rings. Graphite have many layers of carbon atoms. The layers are far apart and they are held by weak forces known as van der Waals forces. Now these layers can slide over one another, making graphite soft and slippery. Why graphite is a good conductor of electricity? In graphite, each carbon is bonded to 3 other carbon atoms. 3 electrons are used in the bonds and 1 electron is free. So every carbon atom in graphite has 1 free electron. Now the presence of these large free electrons will make graphite a good conductor of electricity. Now what are the uses of graphite? Graphite is used in pencils and lubricants because graphite is soft and slippery. It is a good conductor of heat and electricity. Because of its high conductivity, it is useful in making electronic products such as electrodes, batteries and solar panels. Now the third allotrope of carbon is fullerenes. Fullerenes are allotrope of carbon having the shape of hollow sphere or ellipsoid and many other shapes. Spherical shaped fullerenes are called Buckminster fullerenes or Bucky balls. Buckminster fullerene is named after the architect Buckminster Fuller. And this Buckminster fullerenes looks like a football. Carbon atoms are arranged in a football shape. It contains 60 carbon atoms, so it is known as C60. In a football, there are 20 hexagons, that is white in color, and 12 pentagons, that is black in color. And all these have carbon atoms in its edges. In Buckminster fullerene molecule, there are 60 carbon atoms. Buckminster fullerene is a dark solid at room temperature. It is used as conductors. It can be used as an absorbent for gases. Now, similar to graphite, it is used as lubricants. Some forms of fullerenes are used in making cosmetics related materials. So we have studied 3 crystalline forms of carbon, that is diamond, graphite and Buckminster fullerene. So for more videos, subscribe to my channel and thanks for watching.